Hello, everyone. Welcome to Being Patient Brain Talks. I'm Deborah Kahn, founder of Being Patient. Today, we're going to delve into intermittent fasting. You've heard me mention this before. I'm a little bit obsessed with the topic right now. Intermittent fasting, of course, is when you take breaks from food from, say, like dinner time to lunch the next day. That is supposed to be good for our brain health and possibly exploring the possibility of staving off diseases like Alzheimer's. So joining us today is Dr. Mark Mattson. He is a Johns Hopkins neuroscientist, and Johns Hopkins is right now studying the topic. Welcome, Dr. Mattson.
Well, it's nice to talk with you today.
Thank you so much for joining us. Okay, let's just start with, first of all, what we know about intermittent fasting and why or if that's good for the brain.
We know a lot about intermittent fasting from the perspective of helping people get their weight down, improve their glucose regulation. Many studies in humans now were comparing 3 meals a day plus snacks to what you described, daily time restricted eating, or another approach that we'd used with a group in England a long time ago. It's now called 5-2 intermittent fasting. 2 days a week, eating only one moderate-sized meal each day. But anyway, compared to 3 meals a day plus snacks, those eating patterns have sufficient time with no food to cause a metabolic switch from using glucose in the liver to using ketones, which come from fats. And so the ketones are a good fuel for neurons. We know that for sure. We also know that ketogenic diets and also fasting, it turns out, can suppress epileptic seizures. In fact, ketogenic diets are still used for some patients who don't respond well to epilepsy drugs. And work in my lab in animals has shown what's going on into the brain to explain that beneficial effect of the ketones. And essentially what's happening is, I have to get in briefly to a little neuroscience. So your brain, if I was to ask your listeners or viewers what neurotransmitters have they heard of, they might say dopamine or serotonin. But it turns out the most abundant and important neurotransmitter in the brain is glutamate. It's an amino acid and excitatory transmitter, and over 90% of the neurons in the brain, throughout the brain, use glutamate. Those glutamatergic neurons degenerate in Alzheimer's disease. And actually, turns out that Alzheimer's patients have increased incidence of seizures. It's actually a lot. It's like 20 to 30-fold over age-matched people without Alzheimer's. So there's this hyperexcitability, unconstrained, improperly regulated activity in those excitatory circuits. Now the intermittent fasting, what it does is it quiets those neurons by actually increasing the activity of inhibitory neurons that use the neurotransmitter GABA. And so anyway, and then a lot of studies in animals have shown that compared to ad libitum feeding, intermittent fasting can enhance learning and memory, and even has an anti-anxiety effect once the animals are adapted to the new intermittent fasting eating pattern. We have ways to provoke and test their anxiety levels. So, and then in humans.
So,
yeah, go ahead.
No, I want to take a little bit of a step back before we get into more of that and understand. So glucose is the normal fuel for our brains, but we can switch energy sources, right? Because ketones cross the brain-blood barrier. So I guess my question is, as we age, obviously we don't metabolize the way that we don't spend energy or burn energy, however you put it, in the way that we used to as efficiently. So is the idea behind this that in fact changing energy source is better for our brains, or is it just that ketones are a better source of fuel for our brains?
Both are true. Those aren't mutually exclusive. So ketones, so you said that our brain cells normally use glucose. That's true if we're eating diets that have carbs in them. If we're eating ketogenic diet or if we're fasting, the neurons switch from using glucose to ketones. And that's been really clearly demonstrated in humans by Steve Cunan up in Montreal, where he had people switch to ketogenic diet, and he measured both glucose and ketone utilization and showed there's that switch. He also showed that, well, another thing with Alzheimer's is that neurons have problems using glucose. That's been known for decades and decades. We don't think, based on Dr. Cunan's work and some of ours in animals, we think that neurons are still able to use ketones even in humans and animals that are symptomatic with Alzheimer's disease.
So the idea is, if we keep, in very layman's terms, if we keep our brains well fed, then it's a harder environment for things to go wrong, such as beta amyloid plaque buildup, later tau tangles. So if we have a healthy energy source, then perhaps it will be harder to reach that tipping point where the neurodegenerative process or pathology begins. Is that correct to say?
Very well said.
I'm trying to translate from scientist speak.
Yeah, that's right. Experimentally, one can show that if you compromise the energy levels in neurons, and this is in animal studies, or even neurons in a dish, if you reduce their energy availability, then they produce more amyloid beta peptide, and they're more vulnerable to being damaged by the amyloid. And they're also more vulnerable to what I mentioned, this hyperexcitability and what we call excitotoxic damage.
So how much of this is actually, I mean, you mentioned in your lab, you're doing a lot of animal studies. What do we know, and what do we need to find out still in terms of relating the research back to humans?
In humans, for people who don't, that's normal people who don't have Alzheimer's disease, we don't know much at all, except that they can undergo this metabolic switch from glucose to ketones in terms of neurons in their brain using them. We have a trial that's almost done at the National Institute on Aging, where we took people between the ages of 55 and 70 with obesity, and they're also insulin resistant. And we put them on either 5-2 intermittent fasting or control eating pattern, which is breakfast, lunch, dinner. And before we started them in the study, and then at the end of 2 months, we did a bunch of cognitive tests and other psychological tests. We're doing functional magnetic resonance imaging to look at neural network activity in their brains. And we're doing some other things that get more technical, trying to figure out, for example, analyzing their cerebrospinal fluid to see if some of the things we saw change in the brain in animals with intermittent fasting also change in the humans. So I can't say anything yet about that because the study's not done. We haven't published it, except it's looking encouraging. But more studies there needs to be studies focusing on the brain in humans. There's a lot of anecdotal things where people will say, well, they skip breakfast, and it's been a couple months now, and in the morning hours, they feel like they're really productive now, and they're able to think clearly and so on. And but from humans, it's just a lot of anecdotal things and not any true scientific
Yeah,
data.
I'm curious about that because like diets are come in and out, like the no carb one, the intermittent fasting seems to be the diet du jour these days. It comes up all the time. So I feel like a lot more people are practicing it. But do we know, there are, like you were talking about, different ways to fast. Intermittent meaning maybe not eat for 12 to 16 hours in spaces, or maybe 5 days eating, 2 days off. Do we actually know what type of fasting leads to better results, or no?
No, we don't. They haven't been directly compared in humans. And it's always comparing, daily time restricted eating to control, which is 3 meals, or 5-2 to control. So we don't know the answer to that. But I should also point out that intermittent fasting is not a diet. A diet is what you're eating and how much. Intermittent fasting is an eating pattern that's independent of diet. Okay.
Fair point. Yeah.
Yeah, and so I consider it like something like exercise. It's something that's natural from an evolutionary perspective. We didn't evolve with
Right.
food in the refrigerator in the morning and so on. We woke up and no, there's not food. We have to go work for it. So
Hunter-gatherer days.
we are adapted. We're adapted. Our brains and bodies are adapted to functioning really well in a food deprived state. If we weren't, we would have never evolved and survived.
Absolutely. Okay. And I want to get to some questions coming in from our audience. Jax Hill is asking, since many Alzheimer's sufferers have very poor diets due to the lack of an appetite, and in the very advanced stages, weight loss becomes extreme, how can fasting or keto diet be useful, I guess, in the context of a later stage of this disease? Or can it, or does it need to be studied?
That's a good question. And I would say it doesn't make a lot of sense to be fasting someone who's already not eating and losing a lot of weight. Down the road, there are some approaches being pursued, supplementing or taking ketones or modified forms of ketones or precursors to ketones, these so-called medium chain triglycerides. But again, yeah, the appetite's a big problem in people. So I'm looking at this more from the standpoint of risk reduction and lifestyle modification, again, akin to getting on an exercise program, something that you continue throughout your adult life.
Right. So longer term, but I want to actually add to that last statement, because, we've talked to scientists before who believe that you can actually supplement ketones. It's a specific type of ketones. Is it beta hydroxy something?
Beta hydroxybutyrate. Yeah.
Yeah, beta hydroxybutyrate. And I actually went on Amazon and they're clearly advertised, right? And so scientifically speaking, can we actually, without fasting, supplement those ketones and they work as an energy source? Because the supplements actually, that energy source goes to, like another supplement, it crosses the brain-blood barrier. Is that feasible?
Yeah, well, so the historical perspective on this is that kind of similar to the popularization of intermittent fasting, which was based largely initially on work in my laboratory in animals, and then some initial human studies we did in collaborations. Ketone ester, the beta hydroxybutyrate ester, a colleague of mine at NIH developed that ketone ester. This is when I was a lab chief at NIH. I was a lab chief there for 20 years, and then I retired, and now I'm on the faculty at Hopkins. But so we tested that ketone ester in our mouse model of Alzheimer's disease. It had beneficial effects. then it's now being tested by Steve Cunan, the guy I mentioned in Canada, in patients with Alzheimer's disease, and also a neurologist that I mentored when I was at NIA is going to test it in patients with mild cognitive impairment or early Alzheimer's disease.
So let me ask you this. If you know, when we enter a disease state in the brain, obviously that's neurodegeneration, but like things like CTE, for example, repeated concussion to the brain, has it been studied yet relating whether or not we can actually help the brain recover using ketones, restoring the energy source and boosting the source? Because I mean, you know, to simplify this, if we can prove that actually ketones can speed up that type of injury, then wouldn't we be one step closer in knowing that actually ketones can help in terms of the disease progression?
There are some animal studies and models of traumatic brain injury that suggest that intermittent fasting and ketones can lessen the brain damage and improve recovery. There's been nothing done in humans along those lines yet.
Let me ask you something that you might not be able to answer, but I mean, a lot of this sounds like, why hasn't it been investigated in humans? Why are we still at an animal study level when it would seem like we could, science researchers could get to the answers to some of these questions, given, in fact, the amount of people and the amount of interest in intermittent fasting today?
There are, I'm really excited about all this because just in the last 5 to 7 years, there's been an exponential increase in the number of human studies. And I was invited with a colleague of mine to write an article for the New England Journal of Medicine a few years ago. And the reason they had 2 reasons for inviting us to do it. One was there's not enough data from humans, particularly people with obesity or insulin resistance, to merit a review article, but also a lot of physicians hadn't heard of intermittent fasting, or they had no idea that there's actually a lot of science, including an increasing number of clinical trials. And so now if you go on clinicaltrials.gov, which is where you go to find all the ongoing trials, and if you put in the words intermittent fasting, there's like 50 trials ongoing in things ranging from cancers, various cancers, diabetes, obesity, mild cognitive impairment, and some inflammatory neurological disorders like multiple sclerosis, for example. So what happened was that the animal research really didn't start till the late 80s, early 90s. And, right. You know, and then it took a couple decades to get a lot of animal data. And then human studies started, and they're taking off now. So, yeah. So
we should be getting more answers, hopefully, in the relatively near. So what do you say to people like all of us in our audience who have either been diagnosed at an earlier stage of Alzheimer's, or who have loved ones, a familial link to the disease? What do we know enough of to start to put to practice? I mean, you know, obviously we're not telling, like you said, this is not a drug or anything. This is kind of a lifestyle change. So what would you tell people? I have a mom with Alzheimer's disease. What should I be doing now to know that I can really boost my brain health for the future?
Exercise, physical exercise, number one. Cognitive exercise, particularly what you and I are doing now, engaging in intellectually challenging things. And then 3, moderation in calorie intake and eating a healthy diet. And I think intermittent fasting can actually help with that aspect. So that's all I can say. There's pretty good data, with epidemiological data, with exercise and people keeping their minds active and socially engaged is another thing during your adult life. There's good epidemiological data with that. There's actually good epidemiological data showing that people with obesity and type 2 diabetes are more likely to get Alzheimer's before they die. And in as much as intermittent fasting can counteract those, one would expect it would be beneficial.
Yeah, and absolutely. And I guess the more we understand about our biologies, it's not so surprising how biological systems relate, to health. This is a good question, and one that, at what age is it effective or good to start to practice intermittent fasting? I mean, would I tell my 15-year-old, hey, you should cut out one meal? Or is this addressed to the 50+ audience? I mean, what age should we start considering this for really health benefits for the longer term?
Well, if your 15-year-old is overweight, it might be worth trying. In fact, I've had pediatricians contact me who work with kids with obesity, and they've had some success in what they do is they get the parents to change their eating pattern, and then the child changes it with them. And then
if they're not obese, though, is there harm to do that at a young age?
No, if they're not obese, then I don't think they need to, until they're fully developed. I mean, you can be healthy without doing intermittent fasting if you get enough exercise and keep your BMI in a healthy range. On the other hand, we do think there are some additional benefits, and that we did one of the studies actually that led to the popularization of intermittent fasting, what we published in 2011 with a group in England. It was in 100 women, and they were overweight, but we randomly assigned them to either 5-2 intermittent fasting or 20% reduction in daily calories, but they ate breakfast, lunch, and dinner. And over 6 months, both groups of women lost the same amount of weight, but the women on 5-2 intermittent fasting had a greater improvement in insulin sensitivity, that is better glucose regulation. So that showed a beneficial effect of the intermittent fasting that could not be accounted for by a simple reduction in calorie intake.
Right. This is an interesting question, and I think it was more geared to people within the audience, but what about volunteer trials within social communities who are participating? I mean, how much science do we really need to come to some of these conclusions about, I mean, obviously staving off Alzheimer's is one thing, but what is the measure that's being used scientifically? And what is it that maybe people can look at individually as to know whether or not their health overall, and maybe even their brain health, is improving or not going down, so to speak?
Their overall health, that's pretty straightforward. They can one thing that we found in animals first and others have found in humans is that blood pressure, resting blood pressure will go down somewhat. It doesn't happen right away. It takes several weeks to at least a month or so. Another thing they could do, what I would do as a scientist, is go to my doctor and say, okay, I'm going to switch my eating pattern to an intermittent fasting one, and I'd like to see if it's affecting my health. Can you take some blood? Can you measure glucose and hemoglobin A1C? It's kind of a,
which is a pre-diabetic indicator, right?
Yeah. And, and they'll take the blood pressure and then switch and then come back a month or two later and see if there's been any changes.
Someone else is asking, so if your BMI is normal, will intermittent fasting help with brain health and all, staving off Alzheimer's? So if you're talking to a group of people who have normal BMIs, do they need to do intermittent fasting, or is it always a good idea?
I can't answer the specific question that person asked. There aren't any data on that. There's a lot of interest by athletes, interestingly, in intermittent fasting. I had an NBA player contact me he'd gained some weight in the last few years, and like the amounts of points he was scoring per game was going down, and so he wanted to help get his weight down. But endurance athletes too are interested in this, the notion that, and there's actually evidence for this, that ketones can enhance endurance. There's been studies done in elite British cyclists showing that this ketone ester can improve their performance. And my understanding is pretty much all the elite, like the riders in the Tour de France now, do that. So obviously they have healthy body weights and they're seeing some benefit. But as far as the brain, we don't know. My guess is yes. And that's just based on my knowledge of what's happening at the level of the nerve cells and the molecules in them. Yeah.
So are there plans to move your research? You were talking about you're currently doing animal studies. Are you going to move them to humans soon? Because I think there's a lot of people probably here who'd like to participate.
So I retired from my position at the NIA, so I actually don't have a lab anymore. What I'm doing now at Hopkins is I'm cheerleading clinical investigators in trials of intermittent fasting. For example, one neurologist, Ellen Mowry's done a couple of preliminary studies in patients with multiple sclerosis, and she's trying to get funding to do a bigger study. There's studies at Hopkins, people with diabetes and so on. But I would suggest go on clinicaltrials.gov, put in intermittent fasting. It's easy to scroll through, maybe whatever, 50 or some studies, and you can see whether you click on a study. But those are mostly for people with some condition.
Right.
And not normal, healthy people.
Yeah.
But,
and this also punctuates like some of the frustration, like why isn't research geared towards health rather than disease and illness? Because, right?
I agree. So in one of the chapters of my book that just came out, Intermittent Fasting Revolution, I have a whole chapter on answering your question, and it has to do with dollars.
Yeah.
Both in terms of, pharmaceutical companies don't want healthy people. I mean, it's kind of cynical view, but they don't make any money from healthy people. And our whole healthcare system is kind of geared to letting people get sick and then treating them. And also, unfortunately, I've been doing research for about 40 years now, and it used to be the NIH would fund a lot more kind of basic studies that aren't really necessarily disease focused. And over the decades, more and more, they've shrunk the amount of funding they give for kind of things in the basic science and prevention, and focus more on disease. Although now there's a little bit of switch. For example, they have had a request for grant proposals for human studies of intermittent fasting, including those in normal healthy people.
Okay, so I want to get to we're getting a lot of questions, but I want to just get to the last few. So I'm going to combine two of them. One is, what is your opinion on the 12 hours during regular sleep fasting? I mean, can we gain enough benefits from that? The second one is, will intermittent fasting help with someone who's had a stroke and they're trying to improve the brain? So again, it's kind of more in the injury. Do we know that yet?
No, there are some animal data. Back in the 90s, we did studies in an animal model of stroke where if we had the rats on intermittent fasting before the stroke, there's less brain damage and better outcomes. Another group in, I think it's Korea, did a study where they did the stroke in the rats, then waited a couple weeks and started intermittent fasting and looked at recovery of motor function. So we have models that, they're very good models actually of human stroke, because we surgically occlude a vessel in the brain. It damages neurons on one side of the brain that control the opposite side of the body. So just as in humans that has a stroke where there'll be, problems on one side of the body, it's the same in the animals. So there haven't been any trials in humans in stroke yet. So we don't know. And then the first part of that question was
is 12 hours enough? So, I eat at 7 p.m. and then I don't eat again until 7 p.m.
No, not really. It's right around there where this metabolic switch occurs, and we think it's important to have that switch fully in place, which takes at least 16 hours.
Okay, so we really need 16 plus.
Yeah.
And then has anyone researched impact of fasting, intermittent fasting, and an underactive thyroid issue?
No.
We haven't linked that yet. Okay.
No.
Okay, I think we've got them all. Thank you so much, Dr. Mattson. We wish you all the luck with the research and coordinating it, and we will keep an eye on this topic. It's one, obviously, that's very interesting and important to our community. We certainly hope that more research will delve into prevention rather than, cure from injury or illness. But thank you very much for your work, and we'll give your book another plug. What's the title of your book again?
The Intermittent Fasting Revolution.
Okay, so and I'm sure it's available on Amazon to our audience.
It's on the science. So there's a lot of science. I tried to write it at a level that's understandable by a lot of people. The way I look at it, if there's things in there you don't understand, that's good, because then you may want to try to understand them.
Okay, so if any of you missed any of this talk, you want to see more of it, don't forget to go to beingpatient.com. We're going to post this talk in its entirety. Also, don't forget to sign up for our newsletter on beingpatient.com, because that's when we let you know when these talks, who we're going to talk to. Your questions are an essential part of these. So thanks to Dr. Mattson for his time and his expertise. And we look forward to checking back in with you at a later date. Thanks very much for joining us.
Okay, I enjoyed it very much. And then the viewers had great questions.
Okay, great. We'll speak again soon. Thanks a lot.